Okay. Jumped through 5,000 hoops, but we did it. Okay. What a stressful day already. Okay. What do we want to do with? Should we just go through or just take random ones? Okay, what'd you say first? 43. And then what'd you say? 38 and 41. All right, any others to toss out there? 28.
Oh, 30. Did I say 31?
Yep. No, you didn't. Okay, we'll add to it if we need to. I'm just going to go the order that I wrote them down. Okay, so let's look at 43. 43. Okay, so Newton's law of cooling. You may put this formula on your blue sheet if you would like. Okay, so it starts out final temperature minus surrounding, or usually it's room temperature, equals initial minus surrounding, e to the kt. So it's same as your normal exponential function. Here's your final initial e to the kt, but you're subtracting surrounding or room temperature to both sides. Okay, so for 43 we have a dish of lasagna that's baked at 350 degrees. What will that number represent? Initial. The kitchen is 71 degrees. Surrounding. After 7 minutes, that's our time, the temperature is 297.2. So we'll just call that final. 297.2. What will the temperature be 15 minutes after it was taken out of the oven? Okay, so first of all, we have to use this info to find that K value. Now, since this item is cooling, K should be a negative number. Okay, so let's plug all this in. So 297.2 minus surrounding equals 350 minus surrounding. That needs to be in parentheses. E to the K is what we're looking for, and time is 7. Okay, let's see here. 297.2 minus 71. We could have done that in our head. 226.2. 350 minus 71. That would be, oh gosh, 279. E to the 7K. Okay, what would I do next? Divide by 279. 226.2 divided by 279 is 0.81075 equals e to the 7k. Alright, so what I'm solving for is in the exponent. That's when logarithms come in handy. I can take the natural log of both sides, and then over here that 7k will come down as a coefficient. Natural log of e is 1, so I can ignore that. Divide both sides by 7. And let's see what we get. Natural log of that number divided by 7. Negative 0.02997. Okay, so now we have that rate of cooling, that coefficient of cooling there. But the question is, after 7 minutes, what is the temperature after 15 minutes out of the oven? Okay, so initial doesn't change. Final is what we're looking for. Time will be 15. So new problem, time is 15. Final is unknown. Initial, all the rest is the same. Okay, so let's set up our equation. Final minus surrounding. Okay, so this isn't changing here. This 350 minus 71, so I already know that's 279, so I'm just going to put 279. E, huh? Oh, my bad. E to the K times 15. Okay, so if you look at the right-hand side of this equation, there are no variables. So just type the whole right side in your calculator, get a number for this, and then add 71 over. So let's see what we get. 279 e to the negative 0.02997 times 15. Okay, so 177.978. And now add 71. And 248 degrees Fahrenheit. Which, it's multiple choice, so that rounded up to 249. Question?
See, like, I had no idea how to do that before.
Mm-hmm.
Now I got how to do it.
Okay.
We just had messed up the. Like, you could give me a different problem.
We forgot to add 7.
And sometimes people will forget to put parentheses around this, and that can mess you up, because if you don't have parentheses, you would look at this and say, oh, let's subtract 350. Did anybody do that? Okay, then forget I said that. I don't want that idea to get stuck in your head. Okay, 38. The radioactive decay of a substance can be modeled by this equation. Okay, so this equation is K times Y. So anytime they give you this little decimal in front of Y, that's telling you the rate that it's changing. So there's your K value. Find the half-life of the substance. Okay, so there are a couple ways you can do this. You can just imagine or assign an initial amount, and then the final amount is half of that. Or there is a formula that you can use, which is half-life equals natural log of 2 divided by K, I think. I'd always have a hard time remembering it, so I usually just set it up. So let's just be simple here and say I start with 1 and I end with a half. Half-life means half is gone. I could do 100 here, 50 here. I could do 2 here, 1 here. But eventually you're going to get down to this anyway. E to the K times time. And then I'm solving that for T. So do you see what I mean? You're going to end up here anyway. If I had 100 here and 50 here, the first thing I would do is divide by 100. And then I would end up with 0.5 or 1/2. Okay, so I'm going to take natural log of both sides. Y'all stop me if I'm not making sense. I'm going to go ahead and bring that down as a coefficient. Okay, that's 1. I'm going to divide by that. And that'll give us our half-life. It'll give us the time that it took for half to be remaining, which is exactly what half-life means. 6.93. So 7-ish years. Huh? Should I type something in wrong?
You left off the 1.
Oh, I drew a line through my 1. Okay, I see. 101, 101, 101. Yep. 686. Okay. All right, question. And that was yours.
Okay, I have a question.
Yes.
How do you originally get those first two numbers like 0.5 and 1?
You can make it up. Anytime there's a half-life, if they don't give you an amount, just pick what you start with. So if I started with 100, then my final is 50. It's going to be half of this.
What would be like an example of popping on numbers already given? Well, say like.
Normally, they don't, in a half-life, they don't give you numbers. Unless it's like they'll
So
give...
you're not going to give us numbers, is what I mean.
Yeah, unless... I'm trying to think of a situation when you would... If I give you the you got it. I think we did the tree ring problem or something like that, or maybe it was a radioactive problem.
Doing half-life
Yeah.
in here, so that's why I'm asking.
It's the same as exponential. It's just you've got that ratio of what you start and what you end with is
I mean, it makes sense.
Yeah. Yeah.
I'll just do something again.
But how you solve them is no different. Okay, let's go to 41 next. The oil. Okay, suppose the amount of oil pumped from an oil well decreases at a continuous rate of 0.10%. Okay, so that's the K value that you're given. Now, it is decreasing, so we need to make it negative. When will the output fall to 30% of its present level? Okay, so this is another situation where you can start with any amount that you want. I think 100 makes sense for me. I could say that I started with 100. And if I have 30% of the, if it fell to 30%, then I have 30 over here. You can use 1 and 0.3. Just anything as long as that ratio of 30% is your final. Okay, decreasing at 0.1. So K is negative 0.1 times T. Let's see, and we're looking for T. When will the output fall to 30%? So let's solve it for T. I'm going to divide by 100. So here you can see that I could have started with 1 and 0.3 because that's what we're going to end up with anyway. Natural log both sides. Bring that coefficient down. Okay, that's 1 divided by negative 0.1. .0397. So that was D. Question on that one? .28. Okay, 28's a little tricky. What do I call this when there are no numbers here and here?
Indefinite.
indefinite. That is when we use what? Plus C. Yep, that's what you're talking about.
Why does it have to be C? They use like
I think it's because like.
Well, you don't know what C is unless you have numbers to sub in and find C. So C just is used because it represents a constant.
I'm not still using Z then.
You could.
I might write a Greek.
But don't use 2 every time.
I might write like a Greek letter down there, and you might think it's a number. No, it's not.
All right. Okay. Is this a U sub situation? How, why do you say yes? You're right, but why do you say yes?
You can do sign.
Okay,
The
so
derivative of sign is what's on top.
okay, so I see a function and I see its derivative there. Okay, so that's a clue that you need to use U. A lot of those things, like on the first page, you need to use U because there's no chain rule being used within the problem, but this is a clue that it's probably chain rule when I see one of the function's derivatives in the problem. Okay, that might be my best integral sign ever because I can't make them good. That one's pretty good. Just have to say that. Okay, so is U cosine, or is U sine, or is U 6 theta plus 4?
Sine is 6 theta.
Okay. And sometimes you get it wrong and you have to go back and punt and try something different. Okay, so if I just use sine, what is its derivative? Cosine times 6, chain rule. Okay, and dx. Okay, so d theta, and I'll lift that off. Okay, so I have this stuff here, but I don't have the 6. So I'm going to divide by the 6. Coefficients are easy. If they're not there, we can work around that. If variables or functions aren't there, we cannot work around that. It means you chose the wrong U value. Okay, so 1/6 du will replace cosine 6 theta plus 4 d theta. Okay, so let's rewrite all of this using U. And I know, Claudia, you tend to do this, and you're not the only one. You'll go back and still mix in thetas and U's. So, like, once you figure out the U thing, then rewrite it only using U, because that's what simplifies the problem. And you're not the only one doing that. You're just the most recent one that I saw doing it this morning. Okay, so I'm going to put my 1/6 out front. All of that is just du. And the 1/6, which I already have. So I've got my du. Then this is 1 over U squared. Okay. That is much simpler to integrate than that. So I would rewrite that as U to the negative 2 du, and then think about how you're going to proceed from there. So we're going to add 1 to the exponent, divide by new exponent. Okay, so that becomes U to the negative 1, divide by negative 1, which is the same as multiplying by negative 1. Okay, very last step, sub that U value back in. Now, I am fine on the test if it's a free response if you leave this sine 6 theta plus 4 to the negative 1 plus your C. But I would also be fine if you put that in the denominator. Of course, if it's multiple choice, then the format will be determined for you. But either one of these would be a fine way to leave that. And was that one multiple choice? It was, so that matches up with D. Yes.
When you like, you make like an integral and you have like 1/u squared.
Mm-hmm.
Why is it squared?
Because remember, u was this whole thing here, and that's what's being squared. I could write this as sine 6 theta plus 4 quantity squared. We just put the 2 there kind of as a shortcut. So this denominator is u being squared. You sure? We think?
Why did I don't understand why the top turns to 1 too. Like, yeah, I know that's du. I know du equals that, but why does it just go to 1? Why does that turn to 1?
Okay, think of this as 1 over sine squared. I'm just going to leave it sine squared times cosine d theta.
I can't see.
There we go. So this part right here is your du. This, it's just like if you had x over 6. That's the same as 1/6 times x. Same thing. Okay, moving on to 31. Okay, some of you saw the easier way to handle this one.
So whatever your du equals, you just change that to 1 if it doesn't numerator period.
Yeah. Mm-hmm.
Like, I'm not gonna like try to worry about why it does that. I'm just gonna like do it.
Okay, so I can split this into 2 different fractions here, which actually makes this problem much easier. So if I change this to 9 over square root of x minus 1, that's, to me, a lot less intimidating than that. From 1 to 4. Okay, do I need u here? No. There's no chain rule being used. No function has its derivative within the problem. So what I would do, though, is rewrite that as 9x to the negative 1/2 minus 1. Okay, so now just term by term, we're going to take the antiderivative. That becomes 9 to the positive 1/2 divided by 1/2 is times 2 minus x. From 1 to 4. So that's 18. X to the 1/2 is square root of x minus x from 1 to 4. Is everybody okay with that? That's 2 times 9. Where'd I get the 2? This one? Antiderivative of 1. Did you take the derivative of it? Any other questions before we move on? It's downhill from here. Just sub in 4. Minus sub in 1. So that's 18 times 2 is 36 minus 4. Subtract 17. 32 minus 17 is 15. Any questions on that one? Okay. Any others that we need to look at? What about, why don't we find those word problems that we worked on prior to the break? And make sure you don't have any questions on those. Yeah, but we have time, so. Yes, yes.
We can have it.
Yes. I just don't think you can do all of it in one day. You'll have some, hopefully, some spare time tomorrow. There could be one max. I mean, the gist of those are that you're separating variables and finding antiderivative, right? Finding the original equation and solving it for y. But yeah, look through those and see if there are any that you want to look back at. Yes, and then also I gave you that handout that had like the old car that was depreciating. Remember those problems? Yes. 35. Okay, in 35, this kind of ties into those AP exam questions because where you're using separation of variables. That's part of each of those. Okay, y is negative 2. And x is 0. Okay, so separation of variable means exactly what it says. You want x's on one side and y's on the other. Often you can just cross multiply to accomplish that, but just be careful that that's really all you need to do. Okay, so everything with y's on the left, everything with x's on the right. I'm going to integrate. Okay, so that becomes 3y squared over 2. 2y. 5x. X to the 4 over 4. And put your plus c over there with the x because our goal in the end is to solve this thing for y. But if you'll notice on this one, it is multiple choice. So before you go too far in solving this one, all they're really doing on this problem is finding C and then stopping. Okay. So I'm not actually going to isolate y in this problem. Okay, so at this point, whether you're solving for y all the way or not, you're going to go back and plug in these two values. So all the y's become negative 2. And all the x's become 0. And we want to find c. Okay, well, that's 0, that's 0. So we just have c over here. That's 4 times 3 is 12 halves. Just going to leave it that way for now. And then minus 4. Okay, well 12 halves is 6 minus 4 is 2 for C. So if you just replace C with 2, then you should be able to find that answer. And it looks like C. Yeah, D doesn't have the 1/4. So C would be correct. Okay, all right. Any of the word problems that we... Good? Okay. All right, so I apologize if any of you came in ready for the test, ready to rock and roll, and I pulled a fast one on you. I felt like that break kind of made us lose that momentum that we had before.
Oh, we definitely did.
And I was afraid that the grades were going to be really bad. And most of
I'll
our grades have been doing really good lately, and I didn't want to ruin that. So we'll just have to make crunches somewhere else. and make it work somehow.
We only have one more lesson. I mean, it's not like it will be fine.
It will be one way or another. It
We have-
will be
we have-
fine, won't it?
We have like 2 weeks.